Right, okay. So to understand why modules are designed the way they designed, we have to go back in time. We have to understand how Go started and why some of the design decisions are as they are. So we'll start with kind of knowing you, and I wanted to ask, what is your experience with Go? If anyone like doing Go for 7 years or more, or maybe 6 years since 1.2, how about 4 years since 15? Okay, couple of hands. 1.8, yeah, okay, and I guess a couple of new folks as well. Okay, well, I mean, that's good distribution. Anyone have no idea about Go at all? Okay, well, that's fair enough. You won't learn a lot about Go syntax on this presentation. Perfect. All right, now about me. My name is Baruch. I'm a Chief Sticker Officer at JFrog, also Head of Developer Advocacy. This is my real business card. This is what it says. They're on this table. I'll explain later why you want to grab one. But on this table as well, there are amazing t-shirts with Daenerys Frogborn of the House Frogarian, Queen of the Liquid Software, Protector of the Artifacts, Khaleesi of the DevOps Pipeline, Breaker of Bugs, and Mother of Binary Dragons. It's all here. So yeah, I think there are enough t-shirts for everybody, so please go ahead and take some. And also, as a Chief Sticker Officer, obviously there are a lot of stickers as well there. I'm going to mention JFrog. I don't need to do like a company pitch about it, because we're going to mention JFrog through the presentation when it relates to what we're going to speak about. So this is all good. I'm @jbaruch on Twitter. By now you realize how entertaining I am, so you should follow me right now. If you are still not sure, my Twitter handle is conveniently on the bottom on each and every slide, so you'll have this opportunity later. A disclaimer. Works a little bit less good in other parts of the country and the world, but it's a must in California. This is, and I'm from Silicon Valley, from Sunnyvale, where our office is. So this is a diagram from an amazing book called The Culture Map by Erin Meyer. If you work in multicultural or multinational company, that's a must read. It is amazing, and it shows where the countries are on this scale of emotion, of expressiveness and confrontation. The most emotional, expressive, and confrontation countries are Israel and Russia. I happen to be from both. So consider that a disclaimer. If I didn't offend anyone during this talk, I didn't do my job well enough. And if I do not apologize. Well, I do. So I apologize in advance. This is why it's here. Yeah. So anyway, with this disclaimer in mind, this is the most important slide of this presentation. I prepared a page for you under jfrog.com/show notes. You go there, you will find the page for this meetup. The slides are already there. The video that I hope is recording, my phone gives me some trouble lately, so it might like reboot in the middle and we won't have the whole video. And then I will just post a video of a similar talk and for another meetup. I hope you will excuse me. Hopefully it will survive and you will have this particular talk with this set of jokes, because the only thing that changes are the jokes. The links, all the links are already there, including the culture map, by the way. The place to comment, to rate, and a small raffle to thank you for coming here. Looking around, you see that your chances of winning are very high. It's an Amazon Echo Dot, which is nice. All you need to do is register, and I will raffle it out next week. As I mentioned, the bottom of every slide, it has obviously my Twitter as the most important piece of information, but also the link to the show notes, the Twitter of this Chicago Meetup. It doesn't have a lot of Twitter traffic, so we can fix that. So let's fix that, and a couple of relevant hashtags, GoLang obviously, and GoSender, and you will understand why GoSender is relevant later throughout our talk. So I think I covered all the housekeeping items, and now we can start talking about Go and Go modules, and we will start with the beginning. Why we had a problem that Go modules had to solve. And it all goes back to history of Go, and you see the design began in 2007. Just to remind you, the first release 1.0 was 2012. 5 years in development, pretty decent for a modern language. We see that for majority of new languages, this is the amount of time it takes. And obviously all the fathers of Go are right there. Robert and Rob and Ken and later Ian Lanes and Russ and everybody. And the reason why Go was even written or thought of are completely inside Google reasons, right? So they had, back in the day, they had all Google source code, all of it was built with one makefile. Right? This obviously was a problem, was performance problem, was maintenance problem. Some results of it we still see until today. Stuff like, for example, monorepo concept that we are going to talk about later. How you take all the source code of all your company development and have it inside one source control, one Git repo. We're going to talk about that as well, but that was obviously one of the results. Also, they weren't very pleased with the languages themselves that were in use back then in Google, and that was a C++, Java. They wanted better. They wanted better language. This is how it came to be, and they came to the point when they need to fix this problem of dependencies. When they had everything in one source tree, and they decided they are going to take what is known as Go approach. Right? We will simplify it as much as possible, and we will create one way to do the right thing. And the simple approach is dependencies are sources, and this is a major improvement over the situation in C++, in which dependencies are binaries. C++ is a platform-dependent language, and it means that if you want to use a dependency, you need to make sure that a binary exists for your particular platform, or build it from sources for your particular platform and hope it will be what the original author intended it to be after it compiles. And that's obviously either very hard to achieve, because if you want to distribute a library, you need to pre-compile it to 40 different platforms so everybody could use it, or you need to write source in such a way that the binary result will be the same for each and every platform, right? So this problem was solved by declaring that dependencies are actually sources, and they will be compiled together with your sources, statically binded in the compilation time. That this is obviously a great decision that ecosystem made the ecosystem thrive. The import that we add in our source code when we want to declare that we are going to use third-party code is actually a URL of a version control, right? And that also solves a bunch of problems of how do we correlate the name of the package with a unique ID of this package, right? If you think about other languages, for example, NPM, in which the names of the packages are just strings that can collide, that do not identify anything, and it's basically a nightmare to maintain, to claim ownership, to fight over ownership. All this does not exist, because if you declare an import as a path to a unique repository in version control, it is unique and there will be no conflicts, right? So this is also great. Dump everything together into one source tree, go path. It makes a lot of sense. In Google's case, they already have everything in one in one source tree, and then we compile everything together, and then we're done. Right? Which is simple, makes sense, learned a lot from other languages and built on top of that, which is great, but not perfect. It's not perfect because how do I know which dependencies do I use? I mean, I have a source tree in which there are folders, directories. At best, I can remember which directories are mine and which directories are third party. Probably if I follow the naming convention in my version control, I will be able to distinguish between code that is written in my organization and code that is written outside of my organization. Which dependencies did you use? I look now in someone else's code. How do I know which code is theirs and which is a dependency? Which dependencies I should use? What is the unit that is called a dependency? How can I search for this unit? How can I reuse it? How can I know if it's my code that I edit right now? And that sounds like, well, you should remember your code, but who can recognize their code from half a year ago? And you know what? That's the easy problem. How about internal dependencies inside the organization? Another team wrote a library that I want to use. The URL looks exactly the same. We both come from the same company. How do I know if I now fix a bug in my code or actually stepping over someone else's code and fixing a bug that exists in their code at all? Right? So basically, it's hard to know what's going on. And Dave Cheney here, he's one of the big names in Go community that adopted Go in their organization very, very long time ago. And they resorted to email semaphores to know when they work in two different teams which are codependent on each other, to know when do not touch this code, I'm working on it now and trying to fix something. And you can realize how well email semaphores work, right? So that was a real hard time. And back in the day, a lot of people asked those questions, the Go core team in Google. And they asked when you are going to fix the dependency problem, when we will have a proper dependency management. And the answers were unsatisfying. So here's, for example, Brad is saying, check your dependencies to your own version control. So he said, take someone else's code and check it to your version control. And another suggestion from Andrew, it's not a role of tooling provided by the language to dictate how you manage your code in production sense. Basically, they say, it's not our job, go ahead and build your own dependency manager. And he also said, if you need to build a tooling around what Go uses, you already understand those tools, so it should be straightforward to integrate with whatever system you are. So basically, we expect you to have a homegrown dependency manager. And Brad again, speaking about go-get, and go-get, that's the mechanism of bringing third-party code to your Go path. And that was the dependency manager in Go. And he said, well, it's nice for playing around, but if you do something serious, you need to realize that you do some crazy stuff. So don't do that, basically, right? Don't trust what we do. And that's, obviously, those answers brought pressure to the community to come to the solution. And obviously then, next thing you know, there are 19 dependency managers. And 19 is not, just a figure of speech. There were literally 19 dependency managers for Go before Go module was introduced. You probably heard some of them and worked with some of them, so we will do another quiz. Who knows go-deps.json file is a declaration of dependencies for which dependency manager?
Go-dep.
Go-dep. Now, why it's go-dep and not go-deps? Because there is another dependency manager that is called go-dep, and its dependency declaration is declared inside a file called dependencies TVS. Okay, Out of the following, govend, govend, goven, and gv, which are truly existing dependency managers?
All of them.
All of them, obviously, there are 19, so those are 4 of them. Trash, garbage, and rubbish, how about that?
Trash was one.
Yeah, exactly. So trash is a real dependency manager from Rancher, by the way. Great guys. There are some explanation why they called it trash. It stands for something I don't even remember, but I mean, okay. How about weapons manufacturer? A dependency manager named after a weapons manufacturer.
Oh, I think I did that one also. Oliver. No.
It actually makes a lot of sense when you think about it. It's Glock,
Yes.
standing for Go Lock, G Lock.
Yes.
Yeah. So you understand there was a lot of segmentation in the community. Let's call it that way. And what all of them had in mind is they all relied on the concept of vendoring. And the concept of vendoring that I will explain in a second goes very well with this concept of go path, when you have one source directory for everything, and go path is actually just a subset of monorepo that you have inside your organization that only deals with Go source. So again, the concept of monorepo as it came from Google got some traction, a lot of that because of Google. So this is a subset of a YouTube search of talks about monorepo. They really speak about that a lot. There are some companies that started to adopt this concept. Anyone here works with monorepo? Yep. So here we go. So there are some advantages, and especially the advantages are very clear when you work with Go pre-Go modules era, because GoPath is essentially a monorepo. But it's not for everybody. A lot of people like their clear separation between different repositories for different projects, and the fact that they were pushed to this GoPath obviously also created some resistance, but it was very easy to create vendoring for GoPath. Now, there are two problems with GoPath and with monorepo as well. The first one is it only allows a single version of any given package to exist at once. Right, so think about it. You have two different projects. Those projects are in one source directory. They use a third-party dependency, which is also copied to the same source directory. But they need different versions of this third-party project. How can they achieve it? They cannot. There is no simple way to do that, because they have the source files of the dependency copied in the same source tree, and obviously a source file in a given moment of time can be in only one version. There is only one set of bytes that is there, and that represents a version, which can be only one. So that's one very big problem, and the other is we cannot programmatically, sometimes even humanly, but programmatically never differentiate between code the user is working on and code they merely depend on, because it looks absolutely the same inside our source tree, right? So those are the two problems of GoPath, but vendoring has much bigger problems. And vendoring, I will claim, is the worst kind of forking. What is vendoring? Vendoring is what Brad Fitzpatrick told us to do when he said, take other people's code, dependencies, and commit it to your version control. This is basically vendoring. And copies all the files at some version from one version control repository and paste them into a different version control repository. That's vendoring repository. This is what Brad suggested. This is the whole idea of dependency management in Go. When you check out someone else's code, you commit it in your version control, and now you have it controlled. Now, everything is wrong with vendoring, literally everything. When you take someone else's code and copy it into your source control, you lose the history, the branch, the tag, all the commits, everything. Pulling updates is impossible. you now have a copy which is not related to the original. So when the original moves forward, you stay behind because you just don't know, and there is no easy way to pull updates. It invites modification, divergence, and bad fork, because now they are moving forward and you are moving forward with their code, because you need to fix bugs, you want to make improvements, and you diverge, and there is no link between them. It's completely lost. It wastes space, that's the least of the problems, and obviously good luck finding which version of code you forked. Right, because you forked some commit back then, and this information, which commit you forked, is completely lost. Fighting all those was the purpose of all those dependency managers. They tried to track down, especially the last point, they tried to track down which version you actually forked, so you will have some type of control. And when you updated their metadata files, these go-deps.json and dependencies.tsv or whatever, they actually pulled another version from the other people remote version control and copied them over the version that you had in your version control, and kind of keep track of what happened. But obviously it was a hack and a band-aid over problem of vendoring. Usually in the bigger groups, someone would stand up and shout, wait a minute, we use submodules for that. Now, Git submodules solve some of the problems, because Git submodules allow you to have a module of other people, like source of other people, checked out in your directory tree. So it kind of solves the problem of linking back to the original package, right? Because it's actually a checkout. This is like a Git repository inside my repository. That's the idea of submodule, and it solves some of the problems. You still have no idea what version are you using, unless there is a dependency manager that knows how to work with submodules and tracks the version, and those exist among those 19. You have to connect each dependency as a submodule manually. Again, unless there is a tool that knows how to do that. So if I use one of those dependency managers and I declare a new dependency, it will go and connect a submodule for me, which makes life a little bit easier. But obviously stuff that is being traditionally hard with Git submodules, like switching branches and sharing, switching branches is just horrible in submodules. And there is a problem of when I'm dependency for another team and they dependency for me, it's impossible to do because we need to be submodule of one of each other, and that's not supported. So it's a little bit better, and dependency managers help, but it's still, vendoring is still a wrong solution to the problem. And so now what? Okay, so we have this 8, 10, whatever years past with all this legacy, and we have those 19T, the dependency managers, and people kind of suffer with this vendoring concept, and now we need to decide how are we going to make it better? How are we going from there, and how can we fix it? And the Go team did something very smart. They started to experiment. They said, if someone in community want to come up with ideas of how to do it better, we will be happy to see how it plays out, learn from it, etc., etc. Experiment was called go-dep, and go-dep was a third-party tool that integrates with Go to manage dependencies in a completely new way, without vendoring. And SEMVER, he's an influencer in the Ruby community and helped a lot with Ruby dependency managers. So he was up to a challenge. This is what he wrote in his blog. You woke up this morning, rolled out of bed, and thought, you know what? I don't have enough misery and suffering in my life. I know what to do. I'll write a language package manager. And he's completely right. It is a horrible, horrible idea. And after working on go-dep, he came up with those conclusions. Software is terrible. People are terrible. There are too many scenarios. Nothing will work for sure. It's mathematically provable that nothing will really work for sure, and our lives is meaningless perturbation of swirling vortex of chaos and entropy. Now, we in JFrog feel for Sam because we deal with dependency managers for 11 years now. Our main kind of the oldest and the most known product of JFrog called JFrog Artifactory. Anyone heard about JFrog Artifactory? It's an artifact repository that.
Can you say that again? Sorry.
Can you say it again, please? What it is? JFrog what?
JFrog Artifactory. And the link is obviously in the show notes page, and you basically go to jfrog.com, you're in the right place. It's an artifact repository for managing artifacts, including being a repository for different programming languages and different tools dependency managers. So it's a dependency manager. So it's a repository for Maven, which is Java dependency manager, and for Gradle, which is another Java dependency manager, and for Conan, which is a C++ dependency manager, and Conan is a JFrog product as well. For Ruby gems, for Python PyPys, for R Conda, for Debian, for Yum, 25 different package managers. And obviously we didn't suffer as deep in one of them as Sam trying to write one, although maybe with Conan because it is ours, but we definitely understood how different package managers work, and his conclusions are 100% correct. It looks like, on the surface, it seems like a purely technical problem, but in the end of the way, people get in the way and screw everything up. Because people are unpredictable, don't listen to what you say to them, and basically do stuff that machines cannot cope with, right? Those are people, so yeah, it was hard. Although I have to say that Deb was and still is in some ways is a proper dependency manager. It works, now you can organize your development in project directories. You don't have to have Go path anymore. So you can have like directory per project and they are completely disconnected from each other. And you have a local cache for dependencies. Dependencies are artifacts which are downloadable from artifact repositories and stored in your local cache, and then served when you try to build. They will still compile together, but they are served in the right time. You have proper version declarations. You know exactly which version of which package you dependent on. It has a proper conflict resolution. What version needs to be picked if we have two different versions of one dependency used as a transitive dependencies for your dependencies. So I'm project A, I'm dependent on B, but I also dependent on C, and C dependent on other version of B. Which version should be chosen? How do we make this this decision? What happens if they conflict? If I picked a version, but the build now breaks because the other one can't work with that, all that, that by the way, the core of Sam's suffering, the conflict resolution, because it looks like we can write algorithm of picking a right version, but a lot of times it won't help, it still be a wrong version. Because people suck. Yeah, so conflict resolution, it has, Sam tried to do what he could do. So basically, this is what management looks like in any language. The rest of them, this is what all of them do. And then they had a conflict over conflict resolution. As I mentioned, that's the core of the problem. And Sam Boyer and Russ Cox, the project lead as of today of Go, thought differently about how those problems should be resolved. Basically, Sam said, as I mentioned, people suck, we cannot trust them, and we need to make it as easy as possible for the consumer of the dependency to overcome a problem of a conflict. When Russ says, you know what, no, I want my community to improve, so the solution should come from the author of the dependency. And the consumers should nudge the author to fix what they did wrong, instead of just overcoming this problem, right? Which are, both of the approaches make sense. There was a little bit of nasty argument going on, and since we all love gossip, the links to all of the drama is in the show notes page. It is good, it is good. And in the end of the day, since Russ owns the project, his approach obviously won, and this is where we enter Go modules. And Go modules takes a lot of the experience that go-dep actually did, and this is what's great about it. It was, in the end of the day, successful experiment. It didn't went as is verbatim to as a feature of a language, but still a lot of the same concepts actually exist in Go modules as well. So let's talk about Go modules. First of all, one of the amazing things is, how do we deal with the baggage of 19 dependency managers that are with us for many years? And the way that you go around it is you type go mod init, and that's kind of the initiation of the mod, and then it creates a go mod file, which describes your dependencies. It describes what you use, which versions, and all this stuff, generated automatically, and then everything else just works. You keep working with dependencies as you worked before. You add imports to your source files, and it just get automatically added to go mod file as you type those imports, and everything works the same. So it is some kind of an interesting magic, because what happened? How does it work without us knowing anything new or changing anything or doing anything new? And the way it works, first, it converts all the possible, or almost all the possible legacy dependency managers to Go modules. It will read their descriptors and learn which dependencies and which versions should be automatically added to Go mod file. If you didn't use any of those, it will read your imports in your code and will build again the list of all the third-party dependencies that you use. Obviously, the question is, what version should they use? So let's try to see what happens to Go mod file when you add an import. You added an import in your source file, and then you run go get or build. So Go will access an import that you just added as a URL. And it will check if it is a version control. If it is a version control, it will run go clone command. It will actually clone those sources, will create a module, which is basically an archive of those sources, plus a metadata that describes what it is. And then it will serve a module to your Go source in order to compile them together. Now, if it's not a version control, then we will check if it is a web page. And there are, so basically, most of the imports will go like something like com.github.something, but sometimes it will be those web pages like what's called Go Docs or Go PKG something. There are a couple of imports which are not version control. Instead, they are like statically generated pages of documentation. And in those pages, it's not a web page, and if it's not a control, it's just like invalid import path. But if it is a web page, it will check if this page have an go import meta tag in their HTML code. If the go import meta tag exists, it will follow the go import URL and will do this process again. Hopefully this time it is version control and we can clone it and build it, etc., etc. right? So this is how it works. And if it doesn't have go import, then it obviously fails. Now, the real big problem is how do we go around versions? Because obviously when we add an import, we don't declare any version. We just say we import a certain package, and that's all. And here, this is the conflict between Russ and Sam that I spoke about. And Russ took the easy way out and say, okay, let's take the latest compatible version tag. What does it mean? What does it mean, latest compatible? How do we know which is latest? Okay, that's the latest tag on the releases of GitHub. How do we know it is compatible? And again, what Russ says, it's let's pretend that semantic versioning works. And that's what Sam called, you remember, it looks like it's a purely computational problem. And this is what Russ is saying. Let's pretend it's purely computational problem. Let's pretend that semantic versioning works as intended, and that means that the latest compatible version of 1.x is compatible to 1.0 and up to this version. So now I release a version 1.5.3. It means that it is compatible, backwards compatible, with every released version from here back to 1.0. Those are the rules of semantic versioning, and you as a creator of a package, of a module that other users are going to use, you are expected to provide this behavior. If you want to introduce a change which is not backwards compatible to the .0 of this major version, you have to, by the rules of semantic versioning, introduce a new major version. It has to be 2.0. But if you didn't, it has to be compatible. Now, obviously, the problem is the world doesn't work that way. People introduce breaking changes, which is not backwards compatible, all the time, and do not bump the merger version. But okay, but let's presume that SEMVER works. If it works, we have no problem, because if we add an import pass, we can just easily take the latest tag and it will be backwards compatible all the way, right? Because the latest tag will be somewhere in this 1.x range, and it should be all the way, sorry, I'll shut it up. And it should be all backwards compatible from there. Now, what about version 2? If now we have version 2, the premise is compatible code cannot use the same import path, because we assume that import path is always backwards compatible. And that means that we need to generate a new unique path. An easy and standard way to generate a new unique path is introducing /v2 to the module path. We add /v2. It's very clear what we intend. Then the imports use /v2 as well, and the problem solved, because this is a different path from just my module / my package, and this means that it should be compatible within itself, which means it should be compatible within the range of v2, which is exactly what SEMVER promises you. So it's very easy, it makes tons of sense, as long as we pretend that SEMVER actually works. And this is where, what happens when it doesn't? According to Russ, what we need to the official maintainer of the module and say, listen, you have a version within the scope of a major version, within the scope of the same import path, which is not backwards compatible, fix it, delete it, bump it, do something. Now, Another scenario is someone didn't even do a release. They don't have any tags in their Git repository which are SEMVER named, right? Then a pseudo version will be generated. A pseudo version is something like that. It's going to be versioned 1 before the latest major tag that you have in your repository. If you don't have any tags, it will be 00. And then it will be a timestamp at the hash of your commit. Now, within 0, there is no backwards compatibility guarantees. Version 0 something in SEMVER means it's a beta, it's in development, no backwards compatibility guarantees, or bets are off. Which is cool because that's exactly what it means when I didn't do any tags. If I didn't do any tags, I didn't do any release, I didn't promise anyone anything, you take it at your own risk, there are no SEMVER guarantees, this is the version that will be used and nothing else. As opposite to having a tag which makes that Go will take the latest one, and will if we have a conflict resolution, if someone depends on another version but they are in the same major version, we can expect that if we take the newest one, the older one will work as well. In case of pseudo tags, there are no guarantees. If I use this version directly and another version, also pseudo version of the same module indirectly, transitively, and there is a conflict, Go will not try to solve this conflict for me because we don't have a way to know if those versions are compatible or not, as opposite to when we use SEMVER and everything is clear and supposed to work, at least by idea. Right? So pseudo version, and again, how do we battle the problem of the author didn't give us any guarantees for backwards compatibility? We open an issue and say, hey, release a version, declare your compatibilities so we can use your module and maybe some other dependencies that use your module without an irresolvable conflict, basically. So again, it's up to community to push the authors, to nudge the authors to do the right thing. Now, what if I want to ban a version? What if, or what when, because it will happen, what when I want to ban a version because it breaks some compatibility? There are simple ways to do that. I can specify version X or later. That's the first time when I actually need to go into my Go mod file. Because before that, if everything works, I don't even need to open my mod file ever again. I'll just commit it to version control with my sources. It's get updated automatically. Go now knows how to add dependencies to it when I add imports in my path, and backwards compatibility works, and everything is perfect. The first time I need to look at my Go mod is where I have a conflict which is not resolved automatically, and now it's up to me to investigate what broke what, and either say I only want to use the version that is fixed, or I want to exclude a certain version which is bad and use whatever you can use before that or after that. So this is fine as well. And well, again, this is obviously a temporary solution. In the meanwhile, you as a community go to the author, nudge them to fix that, and provide pull requests to fix that, and work nicely as a group, because Go community obviously is very nice and can fix things together, at least in the eyes of Russ. And who are we to disillusion him of this wonderful utopia? Right. So this is how it works. So basically now in minutes, I think I explained everything or almost everything you need to know about how Go modules work. Come back to work, you open your Go modules or your Go code, you type Go mod init, and boom, you have Go mod file, popular pre-populated with all the modules that you use. You can look inside, you can select your versions, and obviously good luck solving transitive dependency conflicts, but there is no easy way around it. It will break and you will have to deal with it. There are two things that Go does that makes your life very much easier than other languages. First of all, Go mode will include both your direct dependencies and your transitive dependencies. This is very different from a lot of other dependency managers in which you need to write special commands in order to determine what is a real dependency tree, because in your dependency declaration you only see the stuff that you declared. Obviously it makes tasks of troubleshooting transitive dependencies much harder. In Go mod you will see all the resolved dependencies and their versions. It will declare which of them are indirect, it's called, which means transitive, but still you can see very easily what's going on. That's that's number one that makes your life easier. And number two is while you can declare dependencies directly in your Go mod file, if they are not backed up with an import in your source code, it won't build. Which is also very, very cool, because you won't end up with tons of conflicting dependencies that are not even used, but just you added them and then eventually didn't work with them, or more frequently you deleted some code but didn't delete the dependency from Go mod. Instead of doing that, you will most of the time leave Go mode to be auto-generated, and you will just use imports, and Go mode will be popularized as needed, which is super cool, right? So Go makes your life a little bit easier when you fight transitive dependencies conflict resolution, but in the end of the day, it's not fun just because it is a hard job, but it is what it is. So now let's talk about another aspect of managing dependencies now when they are not vendored from someone else's version control. And this is where those modules come from and how can I make sure that my builds are repeatable, reproducible, and the dependencies are immutable. So first of all, modules must be immutable. Your dependencies must be immutable. The construct of module at a certain version, and this is the code that you see in your Go mode. It will be the name of the module at v and then the name of the version. This is how it looks. It has always, once it's introduced forever, refer to the same set of bytes in a version control, always. Now, unfortunately, so basically what is here, that's how it declares. This is the module at version 1.0, should always be the same, should forever be the same. Unfortunately, Git cannot provide us those guarantees, because in Git, you can force push code into an existing tag. So if you remember the way module resolution works, it will clone the tag from Git and construct a module out of it. And if between now and half a year from now, someone force pushed changes to the same tag, I will get different dependency and my build will behave differently. Now, you might say, why would someone possibly do that? But you need to remember that people are horrible. And they won't do it because they're mean, they will do it because they are ashamed. You write a code, and then someone opens an issue, which is so ridiculous that you want to pretend it never happens, a little fix version, because you don't want to create a new version because of this stupid mistake and everybody will get it and will see it in the change log, and that's so embarrassing. So instead we'll just fix it and won't tell anyone. It's like, you know, when you have an outage and you are on call, and you know you all sit in a war room and people are connected remotely, and then you brainstorm what happens, and then someone kicks into them and like, oh, I just fixed it, it's all good. And then like, you want to tell us what happened? No, I don't want to tell you, because it was some stupid mistake that they're now ashamed to admit. So this is the same idea, right? It's not so people do that a lot, not because they're mean, but because they're ashamed and they don't want to admit in their own stupid mistakes and bump up the version for that, which is fine. But obviously it screws the entire idea of immutable dependencies. So what can we do? Instead of going directly to the version control every time and getting those dependencies which changed under our fingernails, we can use something that it was in the beginning called Go proxy, and now the better terms is Go repository, is actually using a repository for Go modules. You use it by just setting Go proxy environment variable, and all the rest remains the same, which is super cool. So now if you look at the diagram of how it works, it looks a little bit differently. So first of all, again, Go will take the URL that exists in the import. But now, instead of trying to understand if it's a version control or not, first we will check if Go proxy environment variable is set. If it is set, then instead of cloning the source from Git, we will check if this dependency in a version declared in my Go mod file exists in the repository. If it is found, it will be served directly from there. And obviously, it doesn't matter now what's going on in the version control. And even if now the author force pushes changes, I won't suffer from that, because now I resolve from my repository, and this resolution will always be the same. Now, if the module is not found, it will 404 on me and say the module is not found, and that's the end of it. And if the Go proxy repository is not set, then we will have exactly the same flow of doing the things the old way. Okay, so which is obviously fine. It protects me from a problem of having those changes pushed to my tag, but obviously it raises a bunch of other questions. How do modules get to this repository? Are those repositories limited to only public code, or I can use it for dependencies that I have inside my organization? And we have answers for all of those, because we keep modules in a hierarchy of caches. So the lowest level cache is the local cache. Actually, Go now reuses the same old Go path directory, which is usually at your username/go, for cache of your modules. The modules will get there if Go builds the module locally from a version control. So remember, we cloned it from version control, we build the module, it will be in my local cache. Or if a module is downloaded from the module repository, it will be cached in the local cache, so we won't hit the network next time we need it. Obviously, it has immediate access, it's on local disk, but it's not shared. So if it works on my machine, it doesn't work on your machine if you don't have the same modules. And obviously, it is treated as ephemeral storage. It can be wiped in any way, I can get a new machine, my disk can be corrupted, there are tons of reasons why this cache can go away. Is organization, and that's your private repository, private organizational repository. JFrog Artifactory is a wonderful example. Obviously, they paid my trip.
It's just
Yeah, so JFrog Factory is not the only tool. There are others, for example, Project Athens, which is an open source project by Go community, and it does the job. It is a proxy, but it's a limited scope. It's only for Go. It doesn't have a UI, and it's basically only like a storage for your modules. When JFrog Factory supports, as I mentioned, 25 different technologies. So if you end up deploying your Go code into Docker images, you need a Docker registry. JFrog is a Docker registry. Or if you run it up in Debian or RPM modules, you need Debian repository, RPM repository. JFrog has that as well. So the universal solution obviously has its benefits. And also we have tools, for example, for deploying modules which do not exist automatically, and the UI, search, and a lot of features, basically enterprise solution. Now, if you set it up on-prem, in your organization, you will need an infrastructure to run it, and it will give you fast access. You are inside your LAN, and you can share modules which are not only available on the internet, but also modules which you create for your own usage, private modules, which is cool as well. Now, if you don't want to maintain infrastructure, again, JFrog Artifactory, you can use it in the cloud as cloud offering. It's still your organizational proxy. You have private access, you declare all the permissions and what's not, but you don't need to set up infrastructure and take care of all that. And you will select the right regions to be present in to provide fastest access to your organization, depending on the cloud regions that you pick, right? So this is kind of a second level. And the third level is a public proxy, public repository. And public repository exists there in the cloud. It's backed up by a content delivery network, so it will be close to wherever you download, the server will be nearby. It's free, you don't have to pay for anything, but obviously it only has open source modules and packages that can be built from an open repositories on GitHub, right? So this is a hierarchy, and in ideal world you should have all three, but sometimes you only have two. So basically, when you set up your Go proxy, you can set it up directly to a public repository, or you can set it up to your organizational repository. If you set it up to your organizational repository will know how to search the public ones, right? So if you have that, you set your Go proxy here. And then the resolution will be check the local cache, it's not there, check the Go proxy URL, which will be your JFrog Artifactory, for example, and JFrog Artifactory will search inside, and for the modules which are not found there, will go to Go Center, grab it for there, cache it here, and return it. Now, Go Center is awesome because it will know how to go to GitHub for the URLs that does not exist here. Clone, create a module, save a module here, and then serve it back to Artifactory, which will serve it back to your local cache and to your compiler, right? So you are protected against this scenario by using this hierarchy, or at least those two. Now, again, there are alternatives to Go Center. Google recently came up with a repository of their own. It's also kind of simplistic. It doesn't have the UI. It doesn't have a search. It doesn't know how to go to GitHub, clone, and build packages which do not exist. But since it's from Google, they hard-coded it as a default Go proxy in Go 1.13. So if you work with 1.13, you will automatically work with Google's proxy. I remember they sue Microsoft or something similar of binding Internet Explorer with Windows, but I guess that will be a little bit of double standards. we will probably not sue Google. Instead, what we want to do is we want to provide more value. So we want to convince you as developers to work with GoCenter, not because the court told you so, but because you actually see more value. So for next like 10 seconds, 10 minutes, I would like to talk, after I finish that, a little bit about what we plan for GoCenter and if it will be useful for you or not. So, but first let's finish the topic of immutable and repeatable builds. So immutable dependencies, the best way to guarantee issues is force push. The best way to guarantee lack of issues is not going to GitHub, but instead going to an immutable repository. Lost dependencies, left pad of Node.js and other wonderful stories, right? You remember that, right? So it is a JavaScript library, 12 lines of JavaScript code, which literally pads text with spaces from the left. This is why it's called left pad. Apparently, JavaScript world needs a library for that.
I don't speak for, I can't speak for the entire community.
Did you use left pad?
Well, I think that the truth is that everybody needs left pad.
Exactly. Everybody used left pad because it was transitive dependency for everything. And when the developer of left pad took their packages and went away from npm.js, it broke the
because
entire...
package management is terrible.
And immutability is important, and everybody learned their lesson, and hopefully all those people now use JFrog Artifactory to protect themselves from those, but also central repositories like npm.js and GoCenter are immutable, and you cannot just take your stuff out of GoCenter or npm.js since then, for that matter. But yeah, obviously, and internet issues you can even build when GitHub is down. So you don't have that excuse anymore. And obviously using a Go repository makes the build faster just because now you do less things, but instead you do more efficient things. Remember git clone and packing it up? You don't need it anymore. Instead of you do HTTP get and you get the package, right? So it's more efficient because HTTP GET is a more efficient protocol than git clone, and you don't need to archive everything up. So basically, in the end of the day, your builds will be faster. How much faster? We don't really know because it really depends on how many modules you use and how big they are and how slow the connection to GitHub is this day. But we see everything between 3 times faster to 10 times faster, and it really depends. So you will get the speed in, right? So now going back to the question, what will make you go to GoCenter instead of just using what's already built in? So first of all, we already have the UI, and this UI have search, and when you look at the package, you can already see the documentation and some stats on how many modules are, how many projects are dependent on this module, how many downloads, how many stars, all this type of things. In the future, we want to help Russ with his vision of let's the community nudge the bad creators of libraries. So, for example, if a library doesn't have a tag, which means it doesn't have a version, which means they don't provide any compatibility guarantees, there will be an easy way to open an issue or upload an existing issue for them to get serious about their versioning. So this is another feature. Ratings. I'm most excited about that just because I'm judgmental Russian Israeli, and I want to grade dependency and saying this is a great dependency and this is a piece of shit, just because it's fun. But obviously when we talk about ratings, we need to understand who the judges are, because what we don't want is to have the community to say those ratings are unreliable, you just invent them, but it's actually incorrect. So what we want to build is a formula, open source formula, of how we grade the dependencies. And this open source formula already exists. The link is in the show notes. But basically what we factor in now are stuff like number of modules dependent on this module. This is, for us, the most important rating of usability. If a lot of other modules already use this one, it's probably not that bad. Another stuff, number of stars. This is a little bit vanity and can be played, so it's obviously a little bit of less of importance. And then number of forks. This is also people fork for different reasons, but also it shows some importance of the module, so it has some weight. Number of downloads in the module. This is, it looks like it's a good metric, but actually CI servers and robots can tweak this metric. So it has some importance, but not very high. Is the project is deleted? Now, if the project is deleted, for me, it's like F automatically, right? Because yes, we have this module, we already cached it, you can use it, but you really shouldn't. Is there a README available? I mean, this is good. Is there active development GitHub project? Is there a license available? In the future, we want to model this elaborate. Is it a friendly license? Because we know how to grade licenses based on their friendliness to developers. Is there active contributors for GitHub project? That's like the buzz factor. If there is one contributor that lost interest in this project, you probably should stay away. So when there isn't one active contributor, it's a little bit of warning sign. And this is just the beginning. So we have some future plans, for example, security vulnerabilities. JFrog has a security vulnerability tool called JFrog X-Ray, in which we check the artifacts inside Artifactory against external databases to see if they have any vulnerabilities. It's hard to do with Go because we just got started with having artifacts in Go as the dependencies. So obviously it takes time to correlate existing vulnerabilities in Go code to these new artifacts which are Go modules and have this vulnerability, but we are working on that. Unit tests and linters, so there are resources that already know how to grade Go projects based on the quality of code, and we might very well take their grade into consideration into our grade, and stuff like number of dependencies. If I have a dependency that relies on tons of different other shit, my dependency is not very reliable. Not because I didn't do a good code, but just because I depend on tons of other people that have to do a good code, good work in order for me to succeed. So generally minimizing the number of dependencies is a good pattern for a reusable artifact. So this can be important as well. But if you already have dependencies, we have them in Go Center and we already rated them, so we can affect your rating based on the rating of your dependencies, right? So and all of that we come with a grade, and this grade is not a guidance, right? So if you look now for an HTTP package and you see one is A+ and the other is A, it doesn't mean that you should take the A+ because it's better. For your scenario, the other one might very well be fine, and the difference is not very, very significant. It's like, thinking about it, it's like consumer reports. When you pick a dishwasher, I mean, you won't automatically pick the top one just because the ratings. You will look if it actually serves your needs, if the features are to your liking, if it's the right color, or whatever are the important metrics for you. But you won't even look at the dishwasher which has a rating of 30. And you will start something about like 60 and up. So this is kind of the same thing. You will be able to filter the results, show me everything of B and up, and then you will have you will spend less time on validating different scenarios with different libraries, and this is what we are trying to achieve. Right, so with that, show notes, JBaruch on Twitter, right? Let's fix the problem of this Twitter handle, and GoCenter.io I can show you now, or you can just go ahead and see for yourself how it looks. So, join the army, they said. See the world, they said. I'd better be sailing. Anyone is old enough to recognize the quote? Warcraft 2? Yeah, no, it was one of the games that I played. But anyway, we're hiring tons of folks for developer relations, doing what I'm doing and doing what Sarika did when she engaged with this meetup in order to organize today's talk. If you are interested in the career of a glory of business travel, meeting strangers, and eating mostly pizza, you can say. I'm just kidding, it's a twin joke really. My business cards are on that table, grab one, let me know, and we'll talk about that. So this is all that I have. If you want to see how GoSender looks like, I'll bring it to the other screen. GoCenter.io. I don't have any, but yeah, you'll have to do it by yourself. But basically, you go there, you see the UI, which is already improvement over our competitor, and you can search and filter and see some of the stats. Rating are coming. If you have any ideas about the rating, go to you'll see there a link to GitHub, and there is a page about ratings in the wiki, and it actually refers the YAML file that I showed you itself. So that's for the purpose of seeing PRs opening against this file and having issues opening against this YAML file and actually doing a better job for everybody by rating it more fair. So with that, if you have any questions. Yes.
Review.
Yep.
Yeah, I actually don't use GitLab, but I hear that several friends that are like moving into GitLab. Are you supporting GitLab?
Yeah, we support everything that Go supports, basically, right? The idea that dependencies are necessarily a URL to a version control comes from Git, and we go with it. So they support GitLab, GitHub, Bitbucket, and I think one or two others, and whatever works for them will work for us as well.
Do you have a same concept as Google talked about localization of tools?
Okay, so here is an interesting discussion. Thank you for bringing that. That's another interesting story. That's more of a stories thing. So, okay, now we have our repository and we have some artifacts version, and Google has their repository and they have some artifacts version as well. Now, what happens if the sequence of bytes that called my module version 1 in GoCenter is different from the sequence of bytes called my module version 1 in Google's proxy? Who is right? We spoke about immutability. We spoke about that this should never happen, and they actually should be the same, but here we are, they are different. First of all, how that can happen? Probably we created our module from a Git tag that later was changed with force push. And when they came and created the same module, they created it from different sources. Now, there are a lot of different approaches to fix that. And I would say the simplest approach, as Go-like, is finders keepers. Whoever created the module first has the golden module. This, what it was in some point of time, and it should be this array of bytes forever. Does it make sense? It makes sense. I would expect Russ to say, it makes sense. It's simple, as we like it. But that means that now Google repository should rely on GoCenter when we have those conflicts. Because we obviously had all those modules before they had them, just because they are new. And this is something that Rust cannot do. So the concept now is we will have independent repositories. We will have some artifacts, they will have some artifacts. Now, there will be another type of servers, which will be the notary servers. And those notary servers will only have the correct checksums. So those notary servers will be a dictionary that will say, my module version 1 checksum is that. Whoever have this checksum is right, the others are wrong. Now, obviously it's an overcomplication, but that's fine. The problem is who can run those servers? It cannot be JFrog, it cannot be Google, it should be some third-party authority that will have zero interest. They shouldn't run the modules repository themselves, and they should devote time and resources in doing this pointless thing of having the record of who's there first. Not surprisingly, there are no takers. So there is no one ever expressed any interest in being this notary server. So for now, this problem is not solved.
Google doing that? Google isn't just saying that Google is going to be notary?
They cannot be notary because they have a repository.
Okay. Microsoft is not ready.
Microsoft, it's not about they're not ready, they plan to have a repository themselves. If they now,
There's more money in having the repository.
Of course. If they now start this notary thing, they forever are banned from having a repository. For some weird reason, no one wants to run a notary server.
What about the pre-software?
There are no takers. Maybe they will do it, maybe they won't, but we hope that we will be able to convince Rust that the first appearance of the module is the golden module, because this is what makes sense. Especially because, and it already happened, subsequent builds of artifacts from the same source might even produce different artifacts.
Oh, yeah.
For example, the archive includes go-mod file. The format of go-mod file will necessarily affect the checksum of the artifact itself. Now, go-mod is a half a year old. What are the chances that go-mod file format will never change? Now, if Rust decides to change it, we will have the same code built with a previous version of go-mod with one checksum, and the same source. No one screwed up the source. There was no git force push, but we just built it with a later version of Go. There is another checksum. Now who's right? So yeah, so that's an interesting question. Dependency management is a nasty domain. As said. Yeah.
One thing that was interesting to me when I was looking at your slides, not to be confrontational.
Oh, you should be.
Yeah.
That's
but
fine.
like the weight on the maintenance and the weight on how active a repository is. You know, some repositories it just works, and people haven't touched them for years.
Yep.
And you know, it's like, for example, like a great example, an old world example, but it's like left hat. You know, it delivers some value. Does something really, really simple.
What are the chances someone will want to change anything in those 12 lines? They just won't.
Yeah, exactly.
Yeah.
I was curious, how did you end up
Well, so
deciding,
this is not such a big of an issue because it will probably have the server version forever. It will be one single version that everybody depends on. It won't create any conflicts in transitive dependency resolution, and probably no one cares.
And I think it's going to be like the same thing, 4TB versus B4, right? 4TB is something that is used by like lots of people. I think the number of people is going to be huge.
I mean, it's fine.
Yeah.
Now, the problem is if there is active development going on. But then it is it is on the maintainer to actually come up with a reasonable versioning and compatibility guarantees, because it will make their artifact less useful if they don't have that. People will eventually, after running into compatibility issues once and twice and 3 times, just walk away.
In your slides, you mentioned that you run active development
Yeah,
and contributors,
yeah.
but how you don't have contributors if you are active development?
Well, no, the contributors is just a merely number of contributors if you have one or more than one.
Oh,
It's a
not
Boolean-
active contributors.
It's just a bus factor basically,
Okay.
right? If there is one person works on it, there is a real chance that they will abandon this project sooner or later. And even if it's very active now, you should be aware that there is a problem there.
Okay.
Very interesting one for you. I don't expect you to know the answer. But the first thing, I think we already use Artifactory, so you'll be going that route probably. But before going there, we talked about like how it was started like around Go 1. A lot of people wrote their own dependency manager.
Mm-hmm.
We have one of them.
Mm-hmm.
We call it DEPENDENCY.
Mm-hmm.
Like, same as
That's the 20th.
Yeah.
Yeah, okay.
I mean, it's just like Walmart Labs internal thing.
Yeah, yeah,
but
yeah.
We have that. So what it does, it creates a vanity import path for you.
Mhm.
Basically, TP underscore something that you thought
Mm-hmm.
or whatever.
Mm-hmm.
And then you have to be in your Go path, you create a new directory, TB, and then everything will work in there.
Yeah, that's vendoring. Yeah.
Right, and now when you move it to like Go module or something,
Mm-hmm.
you can see like Go module knows nothing about like what
Yeah.
basically TP is.
Yeah.
And this is, if not million, at least 500,000 line of code base that has this problem.
Yeah.
And I'm
So-
trying to fix that, and nobody.
Yeah. So the good news are,
Yeah.
when this slide that I showed about the converters,
Mhm.
it is actually a JSON file
Mhm.
that is used from I don't want to say simple, but a straightforward Go code that does the conversion of third-party version declarations into Go mode. Right, so in your case, I would invest in creating the same kind of migrator that will know how to analyze your versioning information and generate Go mode that will include all that.
That's interesting.
And I think
Very
that's
good.
the most logical path to go, instead of doing it manually for each and every project.
Oh yeah.
You will have your own translator that might or might not be plugged into Go mode init. You might have like your Go mode, the WL init or whatever that will use this converter, will generate the Go mode with everything, and then obviously the migration will be much
No,
easier.
that's a good idea. Yeah, I will look into it.
Yeah. And you have all the examples
Yeah.
of all the other
Convert
dependency
forward.
managers that do the conversion. Yeah.
Cool. Yeah. And there goes my long weekend.
Should be fun. It's Go code. And it's good Go code. It's written by people who know what they're doing. Okay. So don't forget t-shirts, don't forget stickers. Now with t-shirts, I'm not taking them home, so either tomorrow a lot of MediaMath people will have them, or you will have them, it's your choice. And stickers as well, feel free to grab as much as you can. Okay?
Thank you, sir. Excellent. Really good.
So it did die in the middle.